everyone, I'm Won-Lee. I'd like to continue testing hypothesis for mean mu, and I will take sample example for this topic. Testing hypothesis for mean mu is important because it is the basis of test procedure. So I think you understand it well, then the following topics will be easy. Okay, two-tailed test. I took two-tailed test for mean mu. And I took potato field, average weight of a single potato is 50 or not. 50 or not. Okay? We use mu zero usually. Subscript zero means known value, given value. So here mu zero instead of 50. Okay. And we have to use test statistic X bar since it is the best estimator. And X bar distribution, then standardize it like this. But sigma is unknown, so we use S instead of a sigma. Then G becomes to T here, S. Okay, T is this one. Follows T distribution with the degrees of freedom n minus 1. And we use alpha significance level like this from this concept, 1 minus alpha equal to like that. So finally, rejection region for H0 is X bar less than mu 0 minus some value, or X bar greater than mu 0 plus that some value. Okay? Let's see. Okay, there is population. Under the assumption H0 is correct. So mu 0. Population mean is mu 0. That is a, assumption, pre-assumption, actually. Then there are many sample means, possible sample means like this, like that, and so on. So there are many sample means possible, but we get one sample mean, only one sample mean, like X bar. Okay? There are many possible sample means follows this normal distribution. Pre-assumption is H0 is correct. Mu equal to mu 0. Mu equal to mu 0. So from this population, there are many sample means, but if you have sample mean here or here means this value, and this value is this one. Okay? Upper bound, lower bound. If you have sample mean in this area, you will reject H0 because your sample mean is far from mu 0. Big difference, say statistically significant difference. Okay? Understand it, I think. Okay, let's see a little more about this. Sample mean X bar is less than mu 0 T alpha over 2 square root S over square root n, or greater than that value, this value, then we must reject H0. This is because the sample mean value X bar is far from mu 0. Therefore, even though mu equal to mu 0, population mean is given value mu 0, making incorrect decision, H0 is rejected, leads to an error. Here, mu 0, this probability is what? Alpha over 2, here, alpha over 2. Okay? This value is here, that value is that. Right? Even though this sample mean X bar is from that population with mean mu 0, but it is far from mu 0, so you reject H naught. You make what? Type 1 error. This is the probability of type 1 error here is alpha, significance level. You understand that? It is a little delicate, you know, confusing concept here, but I like you understand what I'm talking about. Here, two values, mu 0 minus t alpha over 2 times s over square root n, same amount, plus, called critical values. This is critical values. This is because these values serve as boundaries for making entirely different decision, right? If your sample mean is less than this value here or greater than this value, slightly different, then your decision is all right. It is a question. Therefore, it is valid to perform hypothesis testing using the significance probability. Significance probability is a new terminology, say p-value, will be explained later, coming soon, rather than setting a fixed significance level, say alpha. Alpha equal to 5%, something like that. So alpha is not always 5%, sometimes 0.01. Even biostatistics, medical school, they have to use alpha equal to 0.001, okay? Because they should not make incorrect decision. Alpha maybe 0.001. So we do not say significance level is always 5%. You must not decide significance level is always 5%. Okay? One tail test now. Population mean mu. Okay? Let's see again the example. That example is lifespan example. Lifespan of electronic equipment product. So H1 is claim average lifespan less than 2000. This is claim. And the other one is H0, mu greater than equal to 2000. It is theoretically right, but you may say mu equal to 2000. Okay? Get rid of this greater than sign. Okay, test the statistic X bar and rejection region for H0 is curious. I said X bar should be less than 2000 minus some value, right? What is some value? This is this one. That triple question mark is T alpha S over square root n. The rejection region for H0 of this one-tailed test will be this way. You don't have to think about greater than, okay? We will concentrate, just care about left tail. So alpha significance level is put down at the left side, left tail. Take care of left tail. Okay? You don't have to both tail. You don't have to think about the both tail, just one tail here. That's why we call this kind of a type is one tail hypothesis. Okay, let's see example. Financial institution claims that if the waiting time for customers exceeds 2,500 seconds, customer dissatisfaction increases. The financial institution measured the waiting times for 7 customers. The 7 values they obtain as a sample. Okay? Assume that the waiting time has a normal distribution because I added this one because it is a small sample. If you have a very big sample, about 50 samples, 50 customers, then you don't worry about this kind of assumption, right? Okay, formulate the hypothesis test whether the average waiting time for customers at this financial institution exceeds 2,500 seconds. Here, this is a claim, argument. And you may say only equal sign for H0. Okay, perform the hypothesis test at the significance level 5%. Okay, let's see. Then sample mean and the standard deviation of sample 7 data points are x bar is 2,571 as 115.1. The t-value corresponding to the right tail This is right tail, right? Right tail of 0.05 with degrees of freedom 7 minus 1, n minus 1 is this value, 1.943. Therefore, rejection region for H0 is x bar greater than mu 0, 2500 plus 1.943 times s over square root n. It is 2584.5. Your sample mean is what? 2571, okay? So it does not fall into the rejection region for H0 because it is what? Less than this value, critical value. So you cannot reject H0. We usually say we do not reject H0 rather than accept H0. It is just some philosophical thing, I think. Not use accept H0 because I think simply it is a known value. 2500, this is a known value. We do not say accept H0. Instead, we say we do not reject H0. Okay? Your aim, your claim is in the alternative hypothesis. So you don't uh, have to, you don't say accept H0. Okay, now same test hypothesis, significance level at zero point 0.1. Okay, let's compare. Then t value will be smaller, t6.1. Therefore, rejection region is x bar greater than 2500 plus now 1.44 times same value. Okay, 2500 61.6. Now, X bar is included in this area. So you reject H0 at alpha equal to zero point 0.1. When alpha equal to 0.5, you don't reject H0. But alpha equal to 1, then you reject H0. Different result, right? Depending upon the significance level. So we need significance probability, and we will see how to use significance probability. Okay, that's it today. Thank you. Bye.